All right, so let's talk about using alkynes as nucleophiles. And there's kind of a nice advantage to this in that alkynes are not nearly as basic, or not basic enough to really perform elimination reactions, particularly on alkanes. But they are acidic enough that we can easily remove the hydrogen. So to do this, basically we're doing this by creating a carbon coupling reaction. Now there's a few details about this reaction that are pretty important. First of all, you need to have a terminal alkyne. And the reason you need a terminal alkyne is you need a hydrogen that can be removed. So we have something like this, and what we're going to do is we're going to add a very strong base, something that is far more acidic than the hydrogen on an alkyne, something like NaNH2, although that can have other side reactions. Very strong bases like terpene oxide, something that can really abstract that hydrogen. And what we're going to end up with is something that looks like this. Now, this has to be done in a separate step. And the reason why we would prefer to do this in a separate step is that if we have a base that can abstract the hydrogen, there's a possibility that this base can also do substitution reactions on something like an alkyl halide. And the whole reason we're doing this is that we want to do a carbon coupling reaction. So in step one, we use a strong base to produce our terminal alkyne. And then what we're looking for is to do a substitution reaction. So a nucleophilic substitution reaction can take a few forms. The one you're probably already familiar with is displacing halogens. So let's say we have something like 1-chlorocyclohexane. What our nucleophile will do is that it will come in, replace Cl, and we'll end up getting a compound that looks like this. Now, the advantage of this compound is that it's irreversible. So once we do this carbon coupling reaction, we can't do any more. This nucleophile can never be replaced. And in principle, if we do something like PTH2, we could end up creating the alkanes we want to create. Now, the second one, and this really isn't covered in the organic 1 level, but it is more covered in the organic 2 level, is nucleophilic attack on carbonyls. So if we have something like this, and we have our terminal alkyne that's been deprotonated, we can get this compound. If we subsequently add water, we get the alcohol, and then we can subsequently do hydrogenation to create a tertiary alcohol. So we're not going to focus, generally this isn't focused on too much in terms of organic 1, it's just something to add to your synthetic toolbox. But the big thing here with using alkynes as nucleophiles is, one, they're not nearly as acidic or not nearly as basic enough to extract a proton from an alkyl halide or something like that, and because of that, they're very good at displacing halogens to create carbon coupling reactions. And because they are carbon coupling, they are irreversible. Now, this is not something you want to do with an alcohol. Typically, your alcohols are enough that they would actually pull the proton back off us. But again, it's just kind of there to add to your synthetic schemes.